Question 7. Given that z is a complex number, solve the equation z cubed minus 8a equals 0, giving your answers in the form z equals r cos theta plus I sine theta. First thing you would do is rearrange that to say that z cubed equals 8i. The second thing I hope you would all do is draw an Argand diagram. Complex numbers are so much easier if you can see what you're trying to do. So draw a quick sketch of an Argand diagram. 8i is there. So as we can see here, this angle is pi by 2, so that's 8 brackets cos pi by 2 plus I sine pi by 2. Now, if another way of writing that, if you like Euler's form, I think it's useful to look at Euler's form if you're happy with it, but you could still just work with r cis theta form, that would be fine. But it is 8 e to the I pi by 2, which then helps us when we're going to cube root it. So z is equal to the cube root of z cubed. So there must be 3 complex roots. We need to give all 3 of those complex roots to get the full marks for this question. So the first one, we cube root z cubed, we get 8 to the power of a third times e to the I pi by 2 to the power of a third. Clearly 8 to the power of a third is 2, and when you're multiplying, so when you're doing an exponent to a power, you multiply the exponents, so we get 2 e to the power I pi by 6, or 2 cis pi by 6 if you prefer that method. That gives us one solution. If we want to get the other solutions, if we look at our original complex number, it is 8 e to the I pi by 2, but we could also go once around the circle and get to 8, so add 2 pi, or we could go twice around the circle and get to I, so we can add in 2 pi times n. If we want to, we can go around the circle as many times as we want and then stop at I. Okay? And the same works with our roots, so we have these 3 values. So 2 pi divided by 3, because we've cube rooted it, times n. Now in this case we only need 3 solutions, we don't need any more, so we can stop once we've got our third solution. Let's draw our solutions on the Argand diagram. We're going to assume these have a modulus of 2. That is z1. That would then be a third of the way around, that's pi by 2 pi by 3 around the circle, that's z2, and z3 is a further 2 pi by 3 radians round. And they divide the unit circle up into thirds. So 2 pi by 3 between each one. So our z1 is 2 cos in the form that they want it. So r is 2 cos pi by 6 plus I sine pi by 6. That's z1. z2, if we add 2 pi by 3 to pi by 6, then we get 5 pi by 6. So 2 cos 5 pi by 6 plus I sine 5 pi by 6. And the final solution, z3, would be 2 cos 3 pi by 2, that's minus I, plus I sine 3 pi by 2.